All right, so I shared my screen. You should be able to see the screen now. So say yes in the chat if you can see the screen. If you cannot, say no. All right, very good. Okay, so let's start. All right. So today is actually, no, this is incorrect. Today is the second lesson of factoring in polynomials. So this is not a 1, this is a 2 now. All right, so it's the second lesson of factoring polynomials. So I looked at the homework. You guys did pretty good. And today we'll be learning more advanced factoring. So let's go over the homework problems. Let's review what we learned, and then we'll get on with new material. Okay, so let's start. So for this one, just post your answers in the chat, and then we'll go over this one. All right, so let's review this one. So most people got 2x times the quantity of 2x plus y. Very good. Okay, so what you need to do is that you need to find the GCF. Okay, so let's look at each of the terms here. The numerals for the GCF is going to be 2. And then for x, it's going to be x. And then y, there is no y. Okay, so once you do that, you take it out. It's going to be 2x times 2x plus y. And if you want to check your works, you can multiply it out again. And that's how you factor it. All right, so let's factor this one. Dang it. I accidentally closed out of the thing again. All right, hold up. Let me get the PDF out. Oh. Okay, I shared my screen again. Should be working this time. All right, so let's do this one. Okay, so a lot more people got this, I think. So x plus 2 times the quantity of x plus 5, and that is absolutely correct. So let's see here. How do we do that? So what is the main point? All right, so what we need to do is we need to make sure this value, you're going to list factors of it. You're going to find two factors of this value 10 that are going to add up to 7. So those two factors obviously are 5 and 2, right? So then it's just going to be x plus 2 times x plus 5. And if you want to check your work and multiply all of these, to check your work, right? So number 3, all right, do number 3. I'll give you a couple minutes. All right, so let's see any answers. So what we can do here is we can factor out 3 from all of these terms, right? So let's factor out 3. What can we factor from the x terms? Can't actually do anything with that because 18 does not have an x term. And we can't even factor out y either. So all we're left is, what we're left it with is just x cubed y plus 5x squared y plus 6. So you can't really do anything with that. All right. That's it for the homework. So let's review a little bit of factoring. So factoring basically is writing a mathematical identity as a product of two or more less complex identities. For example, 35 is equal to 7 times 5. This is our big number, and these are the factors. But when we do it algebraically, we use variables, of course. So we may be factoring something like x squared plus 7x, something like that. All right, so just a small review on factoring. All right. So the key point of factoring is to find the GCF. So does anybody know what the GCF is? So what is the GCF? Can anybody tell me what the GCF stands for? All right, William, what is it?
It is the greatest common factor.
Very good. So the GCF stands for the greatest common factor. And what you want to do is you want to take out that greatest common factor from all your terms, right? Then you have it factored. Okay? So let's look at this. So if you have something like AB plus AC, each of these identities separated by like subtraction or addition, you can count them as terms. So these are terms. Let's look at each of the factors of these individual terms, because they're just multiplied together. So let's look at the A terms. So how many A's can you take out from both these objects? You can take out one A, right? So we just take out that and write what's left in the parentheses, right? And if you want to check, you can multiply it back, and that's just a distributive property. All right. Okay, so are there any questions? There are no questions. Oh, dang it. I accidentally closed it again. Okay. All right, you should be able to see it now. All right, so let's review what we did on this type of factoring form. X squared plus bx plus c. All right, so who knows how to factor this? What you need to do? All right, what do you need to do to factor this? Who knows what you need to do? Okay, so any volunteers? Let's see, Kaylee. All right, very good, Kaylee. How are you supposed to factor x squared plus bx plus c?
So, first you look at, if you can't factor it, you look at C and you recognize all the factors of it in factor pairs. Like if it was 6, it would be 2 and 3, 1 and 6. So,
Very good.
and then we choose the pair that when you add the numbers together, they equal B. And then you make it so that x plus the first number and then multiply by x plus the other number.
All right, that's exactly correct. Very good, very good. Okay, so Very good. So did everybody understand that? Hopefully there are no questions on that. I think you guys did fine on the homework, so there should not be much questions on that. And today we'll be actually doing a more advanced form of that with an a term in front of the x. But that's for today. Okay, so let's go over our other what we learned, other formulas that we learned. So okay, so I gave you a lot of some useful formulas. I gave you some useful formulas last class to make sure you know them. All right, they're very practical. Okay, so let's name some of those formulas. All right, so who knows some formulas that we learned last time? All right, what are some formulas that we learned last time? You can put it in the chat, or you can raise your hand. Or what are some formulas? All right. Okay, William, can you give us one?
So one formula was that we could do the difference of the square roots. Like wait, the expression is x to the power 2 plus plus y to the power x plus y times x minus y, which equals to 2x plus xy minus xy minus wait, I'm kind of confused.
All right, so let's multiply this. Okay, let's multiply this. So what is x times x?
X to the power 2.
X squared. Okay. What is x times y?
Xy.
What about x times negative y?
Negative xy.
What about y times negative y?
Negative y squared.
Very good. So what happens to the xy?
They get canceled out, and that's the difference of the two squared values.
Okay, good. So this is called the difference in squares. All right, the difference in squares. All right, so everybody remember that. That's very important. You can use that to factor quite a lot of stuff. All right, so let's do another formula. Okay, so let's see who else has some formulas. All right, how about Ethan? All right, Ethan, did you remember any useful formulas from last class?
Not really.
All right, that's fine. Okay, so let's see. All right, good. Elaine has a lot of formulas. Okay, so she has basically the x minus y squared. All right, so if you multiply this and multiply it out, x squared minus xy plus y squared. And the c is going to be x squared minus xy plus y squared. All right, you also have our x plus y squared. Okay, which is, if you multiply it out, it's just x squared plus x squared plus x squared plus y squared. And you can see it's x squared plus 2xy plus y squared. The only difference is that in x minus y squared, you subtract 2xy, and then in x plus y squared, you add 2xy. All right. So make sure you have those down. Those are quite important. We can also learn about the difference of cubes and difference of sum of cubes. but we don't really use that in Algebra 1. So we're going to skip that for now. Right, they're more advanced. Okay, so let's move on to what we're going to do for today. So today's topic is pretty hard, okay? It will be pretty challenging to understand. So make sure you're taking notes, all right? So get out a scrap piece of paper, anything that you have to write down on. So make sure you do that. So it's quite important. All right, this one. So right now we've been factoring x squared plus bx plus c. All right, so just a quick reminder. Let's see. If you factor this, all right, the factors of 6 that add up to -5 or -2 and -3, so you get something like this. X minus 3, x minus 2, right? Quite easy. But now you're gonna have to like add a 3 in front of this. If you add a 3 in front of this, yeah, I don't even know if that's probably factorable. Maybe factorable, but you're gonna have things like this with a 3 in front of the x. They can't use that same method, right? They can't use that same method. All right, so what do you do? So, well, we're gonna write this as this is called a trinomial because it has 3 terms, right? Tri means 3, and gnome pretty much means number, right? 3 numbers. Okay, so 3 terms. Let's write this trinomial as this. All right, let's write it as ax squared plus bxy plus cy squared. All right, so basically y is equal to 1 if it's like this. If it's like this, y is equal to 1. Okay, so now let's set it. Set this to ax plus by times cx plus dy. All right, so let's call up a volunteer. Who wants to volunteer for this example? Any volunteers? It's gonna use you to teach, Zebo, do you want to do it? Okay. No, okay, it's fine. Okay. I was just asking you to multiply these, but it's fine. Okay, so if you multiply them, it's not that daunting. So ac x squared. All right, now let's multiply these two. Okay, it's gonna be what? Ax dy multiply these two is gonna be equal to by cx, and then multiply these two is b dy squared. All right, and you can see that this very ugly thing is gonna amount to basically this is going to be AD plus BC XY plus BD Y squared. All right, so compare. All right, let's see. William. All right, William, could you help us on this? All right, so William, between these two equations, what do you notice that is similar?
I'm not really sure because I don't know where the D came from.
All right, so the D is just these A, B, C, D is just demonstration. Okay, so don't worry about that yet. Okay, so let's look at for similarities. So AC would be the A term, right? AC would correspond to A. Do you agree?
Yeah.
All right, what does B correspond to?
B is A and D. AD.
Plus BC.
Wait, AD plus BC.
Because it multiplies XY, right?
Oh, yeah.
All right. Then C is going to correspond to BD. Okay, so let's write that down. A is equal to AC. B is equal to AD plus BC. C is going to be equal to BD. Now, if we want to factor all of this, we need to look at the factors, of course. Right? You know, when you factor x squared plus bx plus c, you also have to factor, you have to look at the factors of c. But this time, we're not only looking at the factors of c, we're also looking at the factors of a. Let's look at this. So this is what we're going to make an x, all right? Let's say this is A, B, and C, D. All right, x and y are variables. A, B, C, and D denote real numbers. X, Y are variables. All right, so you can worry about that later. But anyways, what is C? All right, so C, this is C. It's BD. B and D are factors of C, not AC. AC are factors of A. All right, this A, and this A are not corresponding. All right, so A is a factor of AC. Okay, so you list factors of them. Right, list factors of them. Okay, and B is going to be AD plus BC. So when you know that you have the correct factors is when they multiply, when you cross multiply and they add up to B. Then if you go across, you can just get AX plus BY times CX plus DY. All right, then you're done. Okay, you probably didn't understand any of that, right? So let's move on to an example. Then you know. Because all of this, it's good to remember. All right, this is how I derive the factoring method. But you need experience, all right? So don't just remember this equation or how you derive this, but just memorize how you do it. You don't need to know how to derive this yet. Okay, so it's good to memorize, but you don't need it. All right, so let's look at this example. So let's set this as ax squared plus bx, bx plus c. All right, so William, I'm going to call on you again. Okay, so William, what is A? What is
A is 7.
What is B?
E is 31.
That's negative 31.
Oh, yeah, negative 31. C is negative 20.
All right, very good. So remember, we need to draw that X, right? So the only factors of A is 7 and 1, right? Or negative 7, negative 1. Okay, so let's list that. All right, and then what are factors of C?
It is 1, negative 1, 2, 3, no, 1, 2, 4, 5, 10, 20, negative 1, negative 2, negative 4, negative 5, negative 10, negative 20.
Yeah, so there's a bunch of them. Actually, so it's gonna be plus minus, plus minus, plus minus, plus minus, plus minus. That's fine. Plus minus basically it just combines positive 1 and negative 1. Don't worry about it yet. All right, but so basically you understand the factors, right? So let's pick 2. Basically, the closer the factors are to each other, the more likely they're going to be the ones. So let's pick 4 and 5, 1 and 7. Let's multiply these. 7. What is 7 times 4?
28.
Plus 5?
33.
Good. Does it work? It doesn't. It doesn't
No.
add up to B. That's because we did something wrong. So keep trying. See, when you get used to factoring, I can immediately see what the factors are. I can immediately see them, right? So if you do these again, what you need to do is you need to switch the 5 and the 4. Add a negative to the 5. Actually, no, not the negative to the 5. Negative to the 4. What is 7 times 5?
35.
What is 1 times negative 4?
-4.
What are those added together?
31.
All right, so we're close. We're close. I was actually right the first time, actually. Dang it. Okay. All right, so let's do it again. So 1, 7. Now it's negative 5 and 4. Now you have it. Negative 5 plus 4 is negative 31. All right, so negative 5 times 7 plus 1 times 4 is equal to negative 31. What does this look like? It's basically AD plus BC. It's AD plus BC. Or is it? Yeah. AD plus BC. Okay? That's what it is. Now, you know the factors. They added to B. Now what you do? You go across. What is across from 1? Negative 5, right? Across from 7 is 4. Now, y is non-existent right here. Y is 1. So we don't need to add a y term. The formula is ax plus by times cx plus dy, but y equal to 1, so it's just ax plus b cx plus d. All right. So if you go across, see that it's x minus 5, 7x plus 4. That's how you factor. Multiply it out. 7x squared minus 35x plus 4x minus 20. You can see that it is the same. Okay. Are there any questions? There probably are a lot. Dang it. Okay. All right. So, all right. This is quite confusing. All right. So, let's do another example. All right. Let's do another example. All right. Let's find a different person this time. And I'll walk you through it. All right. I'll walk you through it. So, our second example. All right. So, who are we going to find? All right. So, all right. Ethan, do you want to volunteer for this one?
Sure.
All right. So, first, what are we going to do? All right. What is A?
7,
What is B?
negative 45,
C?
negative 28.
All right, very good. So we're going to have to find factors of 7, right? So what are some factors of 7? We already know that, right? It's plus minus 1, plus minus 7. All right. Now we're going to list factors of 28 now. So it's basically just plus or minus 1, plus minus 2, plus minus 4, plus minus 7, plus minus 14 plus minus 28. Those are basically its factors. Now, remember how I said usually the factors that are closest are the most likely ones. So let's choose 4 and 7. So always start with those. They're usually the best. All right, so let's make our x, right? So we're going to list factors of 7 here on the left side and factors of -28 on the right side. So that's for 7, 1, 7. Now, let's see. Actually, let's do this. 7, 4. Okay. So, and -4. Okay, so you just gotta try the factors, right? So, Ethan, what is 7 times 7?
49.
What is 1 times -4?
-4.
49 minus 4 is equal to 45. We're close. All right, we're close. We got the signs wrong. Let's do it again. How about let's put the negative on the 7th side. All right. So now it's -49 plus 4. Now it's -45, which is equal to b. All right, so after you know that the factors are correct, what do? Do you go across? Yes, you go across. So now that we have the correct factors, Ethan, what is our factorization going to be? Ethan, are you there?
Yeah.
It's not hard, right? So you just go across. This 1 is going to correspond to the x, so x minus 7, right? So 1 and -7. What about, now do the next one. What is 7 and 4? What does that correspond to?
7x
And
plus 4.
very good. So after you do that, you just go across, right? You just go across. And once you get the factors correct, you just go across. Now, when you're like me and you have factored this so many times, you don't even need this portion. You can just think of it. Mental math, But like right now, when you're just learning how to do this, it's best to list A, B, C, find the factors, do the little cross thing, and then do your factoring. All right, just to make sure you don't make any mistakes. And the good thing about factoring homework is you can always get it correct, right? You can always multiply it back out and see if it works. All right, so if you multiply this back out, it's 7x squared minus 49x plus 4x minus 28, which does equal what we started with. All right, so that's how you check your homework. So make sure you do that. All right, so for this last one, we're going to find another volunteer just to make sure you get how we do this. All right, who wants to volunteer for this last one? Do we have any volunteers? Kaylee, do you want to do it?
Sure.
All right, so what we're going to do first is we're going to list some terms, A, B, and C. So what's A?
A is 2.
Good,
B is 17.
good,
And C is 21.
very good. So factors of 2 are plus minus 1, plus minus 2. Factors of C are plus minus 1, plus minus 3, plus minus 7, plus minus 1. You want to find the factors that are closest to the middle, or factor pairs that are closer to each other. So let's just choose 3 and 7, and we only have 2 to choose from here. So make a cross. So factors of 2 go on the left side. So let's do 1 and 2, right?
And
And for 21,
7 on top and 3 on the bottom.
All right, so does this work? What is 1 times 3
3,
plus?
14.
Does it equal 17? Yes, it does. A equals B. All right, so it does equal our B term. All right, so the factors are correct. Now what you need to do? What do you need to do now?
We
You can just factor it, right?
Yeah.
You just throw across. You go across now. So I'm gonna write the first factor for you. So this 1, so 1x, which is x, plus 7, plus 7. Then you do the second factor.
is it 2x plus 3?
Very good. So it is 2x plus 3. Okay, so if you want to check your work, just multiply it back out. Very good, Kaylee. So that was our last example, and we'll have a lot more examples later on. Okay, so this is how we factor like that. All right, so it's quite complicated. Oh, after you get used to it, it will not be that complicated. All right, so let's. Any questions? Do you have any current questions on this? All right, if not, I would like to go on to the next topic on factoring by grouping. All right, so factoring by grouping, can't really teach it systematically, so I'll just teach with an example. All right, so far we've been dealing with polynomials up to the power of 2 with p squared as being the one with the highest degree, right? But now we have something like this with 4 terms. How do you do that? So what we need to do is we need to group. All right? So we're going to group these with parentheses. Let me group these. All right? So once you find the groups, you're going to factor each of those groups individually, actually. So let's find someone to volunteer. All right? Isabella, do you want to volunteer? It's very easy, not very hard. Do you want to help me with this demonstration? No, it's fine. I'll walk you through it. All right, so you can unmute yourself. You only need to multiply a little bit of things, and I'll help you learn more. All right, so okay, so let's start. So how do you factor this? This is just 1, right? This is very easy. So if you factor this, you just need to take a p2 out of it, p squared. All right, so what is left is 2p plus 5, right? What about this next one? All right, this next one, what can we factor out of 6 and 15? It's 3, right? So you're also left with a 2p plus 5, and guess what? We have 2p plus 5. What is the greatest common factor now? Since we now have 2 terms with a common factor, the greatest common factor is going to be 2p plus 5. Right? And then p squared plus 3. All right. So we're done now because we can use the distributive property to distribute, and then we can can multiply it out to see if they're correct. All right, so that was basically factor by grouping. It's not that hard. All right. Yes, Isabella, very good. You get it now. So it's not as hard as the last one. So you should be able to get this one. It's quite important. So let's do some practice problems. All right. So I'm not going to let you guys do it by yourselves because at this stage we're still learning it. So I'm just gonna get some volunteers and walk you guys through. All right, to save time. All right. So who wants to volunteer? All right, William. All right. Very good. Very good. William. Okay. So William, what do you need to group here?
We need to group 12n to the power 3 plus 4n to the power 2 together, and then 3n plus 1 together.
Very good. So what can you factor out of this first term?
In the first term, we can factor out 4n to the power of 2.
Very good. And what's left?
3n plus 1.
Very good. So we're left with 2 3n plus 1s. Now, how do we do this then? How do we factor it after we get this?
Um,
So we know one factor is 3n plus 1, right? What's the other factor? And let me tell you, this is just 1 times 3n plus 1. So it's going to be 4n squared plus 1, right? Do you understand?
yeah.
Okay. So let's move on to another example. And I'm actually going to let you guys do this on your own. Okay, so let's try this on your own. Let's see how you do. All right, so everybody try to do this on your own. All right, let's see if you do okay on it. All right, so let's try to solve this one. We have some answers, I think. All right, very good. Okay, so let's solve. All right, and for Grace's answer, or Grace's question, so should the numbers in the parentheses always be the same? Yes, it should. If they aren't, then it probably is not factorable. All right, so if you're getting numbers that are different in the parentheses, then it's either not factorable or you made some kind of mistake. Okay, so, but for these, they are factorable. All right, so let's factor each of these groups. So for the first one, you can factor out a 5 and n squared. So you're left with n minus 2. And then for the next one, you can factor in out a 3. So you're also left with n minus 2. They're the same. So you can do n minus 2. And then 5n squared plus 3. And you cannot factor this any further. All right. So that's all I have for today. So great job, everybody. It's a hard lecture, but make sure you review the lecture. I will send the recording link. So make sure if you're having trouble, you can always look back at the video. So if you want to review, okay, and please try doing the homework. Okay, so that's all for today. Thank you. I'll see you next week.
Bye.